One.
Welcome to my channel. This is Mahesh Kumar from Physics Department. Please subscribe my channel. My channel name is Physics and Fate.
I would like to tell about the current electricity. Current electricity. So before going to the current electricity, we can learn some learning outcomes. The learning outcomes of the current electricity are: we can recall the term recall, define, identify, classify, recognize. These are the learning outcomes of the current electricity. So before going to the current electricity, in our daily life, one of the physical quantity is mainly used for the fans and motors and bulbs and in our any electrical appliances in our houses. The term is nothing but current. Current is the one of the physical quantity. It can play a vital role for the using of a electrical appliances. So in our daily life, we can using current in our houses. So we can using the term current is the one of the physical quantity. That means it can be measurable. It can be measurable. So it can be called as a physical quantity. So before going to the current electricity, we can recall the term. Recall means in our electrical appliances we can using the current. So we can recall the term of current. So next, define. Before going to the definition of the current, we can classify the materials into two types. First one, conductors. Second one, insulators. Conductors and insulators. So before going to the current electricity, we can define the materials. What are the materials are used in the current electricity? Those are nothing but conductors, insulators. These are the materials are used in the current electricity. So first of all, conductor. Conductor is nothing but the materials which can allow the current through it is called as a conductors. Examples of conductors are iron, aluminium, copper, and etc. These are the conductors. Next one, insulators. Insulators are nothing but the materials which cannot allow the current through it is called as insulators. Example, paper, mica, and wood, and etc. These are the insulators. So for example, in our houses, the electricity which is coming from the substations or power stations, from these power stations the current is coming from the poles. So the poles consist of a aluminium or copper wires. So the poles consist of aluminium or copper wires. By using this aluminium or copper wires, we can using as a electricity. So aluminium or copper wires are nothing but a conductors. Next one, insulators. Insulators are nothing but again in our houses we can using as a wires. The wires are made up of a rubber material. So it is called as insulator. So we can recall the terms of conductors and insulators in our daily life. So next we can go for the term of definition of current. So current is nothing but rate of flow of charge. Current is nothing but rate of flow of charge is nothing but a current. So I equal to Q by D. So current I equal to Q by D. Here the I represents the current. So current is nothing but rate of flow of charge. So Q indicates charge. So I equal to Q by D. Rate of flow of charge is nothing but a current. So next you can write the units. What are the units of the current? The units of the current is Q is the unit of coulomb. The unit of time is second. So coulomb by second or ampere. Ampere. So 1 ampere equal to 1 coulomb by 1 second. It is the unit of the current. So current, the definition of the current is nothing but rate of flow of charge. I equal to Q by D. So according to the SI unit of Q, the unit of the Q is coulomb. The unit of the time is second. So we can define the current by next. So we can another definition of the current is, so consider a wire. This wire consists of number of free electrons. This free initially the conductor is in open position. These free electrons are in zigzag position. So that means the electrons are traveling in different directions. So whenever we can take in as a the two ends of a wire are connected to the battery. Though the electrons are traveling in a one random position. That is nothing but the electrons are traveling in a particular direction. That is nothing but flow of electrons. So flow of electrons in a ordered motion is called as a current. So initially you can take it as a conductor. The conductor is in open position. Initially the conductor is in open position. That means the electrons are arranging in different positions. That means different directions. Initially we can connecting the without connecting the cell or wire. Initially the wire is in open position. In this condition, the electrons are arranging in different directions. They are traveling in different directions. That is nothing but zigzag position. So these electrons are not on an ordered motion. So whenever we have to connect the wire to the two terminals of a cell, the cell can provide some potential difference. Due to some potential difference, the electrons are moving in a particular order. So the electrons are moving in a particular order. This ordered motion of electrons are nothing but a current. So we can observe that whenever you have to connecting a cell, the cell provides the potential difference. So the electrons are traveling in a particular direction. This direction is nothing but a current. So we can observe that. So the current is always flow from higher potential to lower potential. For example, you can take it as a water. The water is flow from higher to lower. So also wind is flow from higher pressure to lower pressure. In this way, the cell can provide some potential difference. So the electrons are traveling from higher potential to lower potential. It is nothing but a current. So we can recognize that whenever the electrons are flowing through the wire or conductor, this ordered motion of electrons are nothing but a current. So it is about the current electricity. So classify. So current electricity is classified into two types. First one, static electricity. Second one, dynamic electricity. So in our houses, in anywhere, in industries and domestic applications, we can using as a dynamic electricity. We cannot using any static electricity. So static electricity means without generation, without flow of electrons, without flow of charge, the electricity can be generated. This is nothing but static electricity. So dynamic electricity is nothing but by the flow of charge or with the flow of charge, with the flow of electrons, we can generating the electricity is nothing but a dynamic electricity. So the current electricity is classified into two types. So we can classify the electricity into two types is static and dynamic electricity. How can we recognize the static and dynamic electricity means? Consider a one handkerchief. So and a straw. Take a two straws and one handkerchief. Rub the straw with one handkerchief and place the another straw near to the rubbing straw. So these two straws are attracting to each other. That means without flow of charge, the electricity can be generated. It is nothing but a static electricity. So dynamic electricity means, for example, we can take it as a water heater. So whenever the water heater coil is made up of a nichrome coil. So whenever the nichrome coil is kept in the water bucket, so we can switch on the water heater. Button. So whenever we can switch on the water heater, the current is flowing through the nichrome coil. The water can be heated. So the electrons are flowing through that wire, the coil. So electricity can be generated. That is nothing but dynamic electricity. That means electrons are rest position, we can generating the electricity is nothing but static electricity. The electrons are motion, we can generating the electricity is nothing but dynamic electricity. In this way, we can classify we can recognize the electricity. For example, we can identify the conductors and insulators. Simply, I will take a simple experiment. How can you identify the conductors and insulators? So, for example, this is a iron material. This is a conductor. Whenever you can keep these two terminals, the bulb will be glow. This is nothing but a conductor. This is nothing but a conductor. So whenever we are keeping the two terminals of this device, so iron is a conductor, so that the bulb is glow. So another terminal we are keeping as a plastic material, the bulb is not glow because it is a insulator. So another one we can take another iron material. So we can keeping these two iron materials in that place. the bulb will be glow. So it is a conductor. So we can take it as a conductor, the bulb will be glow. We can take it as insulators, the bulb is not glow. So we can in this way we can identify the conductors and insulators. So all of you remember that the current is a major vital role in our daily life. So we can using the current in any way, in any electrical appliances, we can using as a current. So this is about current electricity, a simple brief manner about the current electricity. So okay.